All right, AP statisticians, let's do this. Pause where necessary. When you're finished, get everything in your notes, and when you're done, take the Schoology quiz, and we will wrap up section 1.1. I ask at the end of your notes to write down any questions that may be popped up. Your goal is I can make a bar graph of the distribution of categorical variables when compared and compare related quantities. Recognize when a pie chart should be used and identify why a graph is deceptive. So we have some information here about 10 randomly selected U.S. residents from the 2010 census. A says, who are the individuals in the data set? B, what variables measured? Identify each as categorical or quantitative. In what units were the quantitative variables measured? And C, describe the individuals in the first row. Well, in order to do this, you need some definitions. First, you need to know what an individual is. Individuals are objects described by a set of data. Objects just basically means it can be a person or a thing. A variable is what are you measuring? Like I'm measuring hair color or I'm measuring height. It's going to change for each individual. Categorical variables places an individual into one of several groups or categories. If you know what a categorical variable is, you also have to know what a quantitative variable is. It takes numerical values for which it makes sense to find an average. Hopefully you'll pause at this moment and write all these down. Once you're done writing it down, I want to talk just a little bit more about it. So pause, write it down. And what I want to talk about is I want to talk a little bit more about categorical variables versus quantitative variables. Quantitative variables usually have a unit attached to it. Categorical variables don't. Examples, hair color. Another example would be your city that you live in, your college you're attending. Quantitative variables would be your height, your weight, your age. Now, one thing that people get wrong are these two, zip code and jersey number. These are categorical variables. Although they're numbers, because they're numbers, people want to put them in quantitative variables. But first of all, there's no unit. Second of all, it does not make sense to find the average jersey number of the football team or the average zip code of people in our statistics class. That doesn't make sense. It's a categorical variable. So going back, I'm going to quickly talk about example 1. Then I want you to pause it and answer the question. Who are the individuals in the data? Well, the individuals in the data are the U.S. residents from the 2010 census. B, what variables are measured? Identify each as categorical or quantitative. Well, we can just go across the top here. State is a variable. This is categorical. Number of family members is quantitative. Age is quantitative. Gender is categorical. Marital status, categorical. Total income, quantitative. And travel time to work, quantitative. Again, if they're quantitative variables, you can put units. So the units here would be hours or minutes. In this case, it looks like it's minutes. Total income would be dollars. Age would be years. And number of family members would just be people. It's still quantitative. You can find the average number of family members that someone has. Describe the individual in the first row. We're looking at a female from Kentucky with two people in her family. She is, and I wrote over it, 61 years old, married, makes $31,000. I'm assuming per year, and it takes her 20 minutes to get to work. Again, pause, re-listen if you need to, and write down the answers to these questions. Next, a bar graph, hopefully what you think is a simple concept. A bar graph is a way to display categorical data. That's a big deal. It's only for categorical data. Make a well-labeled bar graph to display this. I'm going to let you do this on your own, but you're literally on your x-axis, you're going to put your categories, okay? And on your y-axis, you're going to put the percent, right? Because that's the label. If you need help with this, I'll help you when I get back. It's something you should have covered in algebra. I don't think it takes much time to go through, or please look at your book if you need more information. I do want to spend a little bit more time on would it be appropriate to make a pie chart for these data? Why or why not? Well, notice right away it adds up to more than 100%. Why is that? Well, you can own a cell phone and an iPad, or a cell phone and a video game player. I know it's a little bit of old data. Most of this will all be in your cell phone now. But you can own a cell phone and a tablet. Now I want to talk more about this. Please write this down and then pause it. Pie graphs can be used versus not used, and I have 2 examples for us. So get that down, and I'm going to go to the next page. My first example is talking about the hours of sleep, and the second example is talking about the hours of sleep. In my first example here, I have 85% of seniors get 8 hours of sleep, 20% of juniors, 75% of sophomores, and 13% of freshmen. Immediately, you probably notice this adds up more than 100%. This is not okay to do a pie chart because this was a stratified sample, okay? There was 4 different hats. You like my hats? They're supposed to be a top hat. They asked seniors how many hours of sleep they got, then juniors, then sophomores, then freshmen, right? And then they found the percentage there. So we could have 4 separate pie graphs. This one could be 85%, 15%, 20%, 80%, 20% 8 hours, 80% not 8 hours, so on and so forth. In this example here, 20% of students get 8 hours of sleep, 28% get between 6 and 7, 52% get less than 6 hours of sleep. This does add up to 100%, and you notice the labels are all students. That means all of the students were in one hat, and they pulled out names and interviewed them about how much sleep they got. This, a pie chart, would be okay. We are not going to make pie charts in AP Stats. You just need to be able to recognize when is it okay and when is it not. Next, deceptive graphs. Please take a minute to write this down, and then I want to talk about it. So pause it, write it down, and then let me talk. When you're looking at this bar graph here, it says percents who agreed with the court. And you see the percentages on the side here. You see Democrats, Republicans, and Independents. And you notice there is a huge jump, what looks like at least, from Democrats at 62%. Excuse me, you guys. To Republicans at 54%. This is very deceptive because they're started at 50. If you start at 50, your next tick mark needs to be 100, 150, and so on. Whatever your first tick mark is, that should be the scale that you use. This one's correct over here. 0, 50, 100, 150, 200, so on. So whoever published this graph was attempting to make it look like Democrats agree way more with the court than Republicans, or at least it looks that way, and you could count how many times more. When in reality, it's only 54 to 62%, which is probably not that significant. The next one here is called a pictograph. If you notice, we're dealing with trash. I don't know all the context to it. But what I want you to look like, if I would change this to a bar graph, I would make the bar graph look like this. What do you notice about the pictures? Hopefully you're noticing that the pictures are not only getting taller, but they're getting wider, which is deceptive. It's making it look like this one here is a lot larger than this one. Is it? Yes, but by getting wider as well, it's deceptive to the eye. The next one here is another pictograph, and it's talking about fruit collected. 1, 2, 3, 4. 1, 2, 3, 4. Now, cherries, do they count as 1 or 2? I don't know. But either way, we have 4 items here, and they're not equal in the bar graph. They should be. That's deceptive. And finally, this is a legit graph that Fox News ran in 2012. It's a pie chart about people who back Huckabee, Palin, and Romney, and you'll notice it's over 100%. So going back to deceptive graphs, you want to watch out for scales, pictographs, percents that don't add to 100, or missing information. Next, please write down this as a goal. This was meant to be day 2, but we're covering this pretty fast. You need to understand data involving marginal and conditional distributions. Describe the relationship and construct a bar graph between 2 categorical variables. Right here we have a conditional distribution. It's a 2-way table. You guys are familiar with this with probability, which will make it easy, hopefully, for you. If it's not, you need to let me know. 200 adults shopping at a supermarket were asked about the highest level of education they had completed and whether or not they smoked cigarettes. Results are summarized in the table below. Immediately when you see a 2-way table, you need to fill in the totals. So let's do this now. Okay, so the total smokers is 32 plus 5 plus 13, which gives us 50. The total non-smokers is 61 plus 17 plus 72, which is 150, for a grand total of 200. Number of high schoolers is 32 plus 61, which is 93. The number of 2-year college is 5 plus 17, which is 22. And I'm running out of room here, I apologize. Then we get 13 plus 72 for 4 years, and that's 85. And that should give you a grand total of 200 as well. My next question here in part A, is this univariate data or bivariate data? I'm not going to write all of these down, so you may have to pause so you can write it down. This is what we call bivariate data. We're dealing with 2 different categorical variables. The level of high school, the level of education, and whether or not people are smokers or not. The next one says, what percent of the adults who smoke, highest level of education is high school? Okay, of the smokers, so we go back to our probability here, right? Of those who smoke, the highest level of education is high school, so we just take 13 divided by our total, and I think that total was 50. Part A, what percent of high school graduates are smokers? I mean, this is getting messy, so let me erase. And again, this kind of comes back from probability, so I'm kind of skimming through this here. What percent of high school graduates are smokers? So of the high school graduates, how many are smokers? So that's 32 divided by, 93. And you can keep them as a fraction. Oh, excuse me, but here it does ask for the percentage. So if it asks for the percentage, you want to give the percentage. Part D, what percent of non-smokers have a 4+ years of college education? So now we're dealing with this column. 72. D, 72 divided by, I believe it was 150, okay? Don't worry about E. And what we could do here, how could we display this distribution? We could do one of 2 things, and I let you do it on your own and ask questions. We could do level of education. So we could say high school, 2-year college, 4-year college, and we could do a segmented bar graph. You don't need that for your Schoology quiz, so I'll quickly cover that on Monday when I get back. It's not a huge part of the course, so we're going to move on. You do need to know what a marginal distribution is, so pause for a second and write down what a marginal distribution is. Okay, so a marginal distribution is the distribution of values of one variable among all individuals described by the table. So if I was going to make a marginal distribution, I could do two different ones. One would be for if their smoking status. So I could say they're either a smoker or not, okay? And then you're just going to put their totals. So the total number of smokers we had were 50, and the total number of not was 150. And then the next marginal distribution we could do would be the level of education. So I believe it was high school, 2-year college, 4-year or more college. And I don't have those total, or I think it was 93. Hopefully, let me look. Yeah. 93, 22, and 85. So that's what we call the marginal distribution, looking at the totals for just one of the variables. The conditional distribution is the chart that we have. It describes the values of a variable among individuals who have a specific value of another variable, okay? When you see the word among, a lot of times that's the total, okay? In the denominator, when you're figuring something out, or the word of, in this case, it's a little tricky, okay? So it says give the conditional distribution of smoking status for level of education. How would I write this? I'm going to say I'm looking at the smoking status. Oh shoot, I'm screwing this up now. I'm sorry. Okay, let me see if I can do this justice. Sorry, forgive me. Again, hashtag sick teacher. Okay, so give the conditional distribution of smoking status for level of education. So what I'm going to do right now is I'm going to give you part of the conditional distribution among level of education for smoking status. The wording can get very tricky, so you really need to make sure that you ask me, and we can go through the Schoology quiz in class on Monday once you do that and talk about it more in depth, especially when I'm feeling better. But if I'm going to do that, okay, so among the level of education, I'm going to go back and I'm going to say I'm going to just look at the high school student, or let's do 4-year. So right here, this is the part of the conditional distribution among the education level for the smoking status, okay? So I'm looking at all the people in that, all the education, that's the status, okay? So how I do that now is I'm going to make it a decimal. And again, the wording's really weird in the book, so you might want to look at that a little bit more just to, what's the word I'm looking for? To support your learning, okay? I think the questions about what is the percent in general is fine, but when they ask you, the wording on the conditional distribution piece is weird. So among level of education, that's going to be my total, okay? So I'm going to put 4 years, okay? And then they're either smokers or they're not smokers. And I'm going to write it as a percent here. So the number of people that smoke is 13 out of 85. 13 out of 85. So this is a part of the conditional distribution among a level of education. So I'm just looking at the 4 years for smoking. And now I'm finding the percentage here. 13 divided by 85 is equal to approximately 15.29%. Okay? Then the non-smokers, there were 72 of them. And 72 divided by 85, or just 1 minus 15.29, is approximately 84.71. So in that piece, when I'm giving part of that conditional distribution, I am looking for a percentage, okay? I am looking for a percentage there. How did I know what my total is? Well, usually it's easy to find the total. It's just the wording, and you'll see that in the Schoology quiz. And I'll know if you get it based off that Schoology quiz. So please forgive me if I fumbled on my words. I want you to do your best right now and try this Schoology quiz now that you've now that you've taken all of the notes. I'll look at the results over the weekend, and then on Monday we'll talk more about, I'll fill in any missing gaps. Again, pause for a second, look through your notes, write down any questions, and then complete the Schoology quiz. Thanks, guys.